This screencast continues our discussion related to section 12.4 of the textbook, in which we're looking at hours worked for different groups in the population, for different populations. We just ran a t-test, which tests the null hypothesis that hours worked is the same for people with a college education, signified by 1 for the variable col, versus people with a high school education. And we decisively rejected that null hypothesis. I'm going to discuss the relationship between what we just did and regression. So let's just run a very simple dummy variable regression. We regress hours on the dummy variable college. And you can see that we get a coefficient estimate of 114.3676, which is exactly the difference between the two groups that we analyzed a moment ago when we did the t-test. In other words, it's exactly the difference in the sample averages of the two groups. We're looking at 43,441 people, which is the total number of people we just looked at, 23,000 with a high school education, 20,000 with a college education. And we get a standard error pretty close to the one we did a moment ago, or actually in the last screencast. There's a different assumption going on here. We're assuming that the standard errors are actually equal for the two different groups, and that's why we get a slightly different standard error. The conclusion is nonetheless that, wow, we're really, really far away from what we claimed under the null hypothesis, that this thing is really 0. So I hope you see that running this regression, we're just basically dividing the sample into two different groups according to whether or not they have a college education. Okay, let's do something a little more complicated. We're going to do the following thing, and I don't expect you to memorize this, but this data command, but we would show you how to do it if we came to that. So by sex, in other words, by male and female, we're going to sort the data, and we're going to run a t-test for the males, then a t-test for the females. So we're going to t-test, do exactly the same t-test we did a moment ago, but we do it for males. Okay, so we have 23,000 males. And we find that the difference between hours worked, sample average of hours worked for people with a high school education is 2,015. For people with a college education is 2,153. These are slightly bigger numbers than what we saw before. The difference works out to be 138 hours. And once again, we can compute the difference in the sample averages, and we can get a t-statistic. Once again, we decisively reject the null hypothesis. Let's do the same analysis for females. So now we've got 20,000 people, high school, 10,200 people with high school education, women, and 10,080 people with a college education. Once again, we're just looking at females. The sample average for females with a high school education is 1,728 hours. Females with a college education, it's 1,853. We get a difference of 125. Okay, and again, we can compute a standard error. The standard error is equal to the square root of the sum of this squared plus this squared, the two separate standard errors, and we're fine. We get a t-statistic, which is huge. We decisively reject the null hypothesis. Okay, well, that's one way to do it. Another way to do it would be to separate by whether or not you went to college and then look at sex within that. So here we're looking at college equals 0, just for high school educated people. And we're going to compare the females. Okay, so for them, male is equal to 0. 10,000 females. This is the same group as we just saw a moment ago, all right? And the males, and we find a difference of 286. Okay, so within high school educated people, women work 286 fewer hours. Okay, that's the sample averages, and those are reflective of the population average. Again, we can draw inferences about the two populations, high school educated females versus high school educated males, and we can say, wow, there's a really decisive difference in terms of statistical significance. Not so much in terms of economic, but 286 hours, that's about, that's more than 5 hours a week, almost 6 hours a week. Okay. Now, we can then look, because we did it by college, we now can look at people, college-educated people, and we can find the differences is 299 hours. Okay, again, females work less than males. College-educated females less than college-educated males. These numbers have shown up before, right, in our different analyses. So we could hunt and we can find that 2153, that is males with a college education. Right, we saw that before. Okay, so that's a bunch of different groups we're looking at, and we can do the same sort of analysis, get the same numbers by running the regression. Oh, and we'll have to wait for it because we didn't quite run the regression. We'll just have to do that in a moment. So I'm going to pause for now. So let's just run this regression. So we're going to do reg, and what we're interested in is hours worked as a function of, let's see, where is it here? Hours as a function of college, male, and male college. Let's get the result, okay? Now, what I want to point to is these numbers, those actually relate to what we saw above. I mean, you can simply hunt for this 286 number. We saw that for a 125 number. And then if you sum 125 and 12, you get something like 137. And if you take the differences, you're going to be able to basically replicate what we saw here. So let me give you a hint. Okay, so 286, where does that show up? Well, that's this difference here. That's the difference between people without a college education, between females and males, and that shows up as this for this coefficient. All right, so there's going to be a homework exercise, and I'll talk about that in a second. Let's turn to the homework exercise. Here it is. Okay, so it starts out with defining the variables. All right, just to show you what's going on, and then it repeats what we did. All right, so this is the last thing we ran. All right, so it shows all the analyses we ran, and then there are some questions. Okay, so first of all, here are the questions. We're going to explain how the estimated standard error, the difference in sample averages, is computed, and that's way back up here. How do we compute the standard error for the difference in sample averages? Write down the numbers and show the equation. Okay, you can use Word's equation editor, or you can just use like a square root symbol. The square root thing, square root of something in the middle here, and you can use superscripts to indicate square terms, subscripts like this to indicate the two different groups. Okay, so that would be SE of college, SE of high school, that sort of thing. Okay, and write down the null alternative hypotheses. We talked about that in the previous screencast. Talk about what's the relationship between the simple bivariate regression and the simple t-test. And then finally talk about this more complicated thing that I alluded to at the end, and explain how the coefficients that we get here are related to these t-tests. Okay, the more complicated t-tests that we did. So that's your assignment, and good luck. If you have questions, send email. We may be able to respond. That's it for now.